The Industrial Revolution took off on the edifice of mechanical engineering. Machines, and more machines impacted human lives in a positive way like never before. But as humankind moved into the mid-20th century, post-World War II, it was electronics that dominated technology and finally ushered humankind into the era of artificial intelligence by late 2022. Hi, you're listening to The Why in History. I am Ajay Kaul, and today we continue on our quest to trace the history of technology from the mid-19th century to the present day. Between mid and late 19th century, the most impactful technological innovation was the incandescent electric bulb and the ensuing electric revolution. When Thomas Edison and his researchers descended upon Menlo Park in New Jersey, the electric bulb had already been invented. Edison and his team were focused on improving the technology so it could be used more widely and efficiently. By October of 1879, Edison's team had produced a light bulb with a carbonized filament of uncoated cotton thread that could last 14 and a half hours. Edison continued to improve upon this and ultimately settled on one made from bamboo that gave the Edison lamps a lifetime of up to 1,200 hours. And this filament became the standard for the Edison bulb for the next 10 years. But what makes Edison's contribution to electricity truly extraordinary is that he didn't just stop at the light bulb. Edison developed a whole suite of inventions that made the use of light bulbs practical. In 1882, with the Holborn Viaduct in London, Edison demonstrated that electricity could be distributed from a centrally located generator through a series of wires and tubes, also known as conduits. He also focused on improving the generation of electricity, developing the first commercial power utility called the Pearl Street Station in Lower Manhattan. And to track how much electricity each customer was using, Edison also developed the first electric meter. Electricity in general revolutionized society by extending the day, transforming industries, and making cities safer. The ability to light homes and streets at night led to longer working hours, an increase in productivity, and new forms of entertainment. Fire hazards and pollution from gas lighting were reduced, and economic growth reached a whole new level through new industries, which laid the foundation for modern electrical infrastructure. One if by land, two if by sea, and I on the opposite shore will be. In 1775, Paul Revere had to rely on visual codes to transmit the message at the start of the American Revolution. But all this changed dramatically in 1843 when Samuel Morse built a telegraph system from Washington, D.C. to Baltimore with the financial support of U.S. Congress. The idea behind the telegraph was sending electric signals across wires, and it originated in the early 1700s. In 1835, though, New York University professor Samuel Morse developed a set of sounds that corresponded to particular letters of the alphabet. This was called the Morse code. But by then, several people had claimed to invent the first electric telegraph. But Morse beat everyone else by being the first to get political backing for the invention and a financial support behind it. So in 1843, Morse built a telegraph system from Washington, D.C. to Baltimore, and on May 24, 1844, the first message, "What hath God wrought?" was sent. The telegraph system slowly continued to expand across the United States, starting with an extended telegraph line to New York. Other companies began taking notice of the impact of the invention and started jumping into the fray. And in October 1861, Western Union built the first transcontinental telegraph network, which allowed instantaneous communication between Washington, D.C. and San Francisco. The impact of telegraph on society was enormous. People could finally connect with friends and family no matter how far they lived. On the political front, the press could get stories about politics faster than ever. And in 1848, when Zachary Taylor was elected president, the election was called by the press before the Electoral College. And this set a precedent for future election results. But the biggest impact of telegraph was in the financial sector, notably the stock market. In the early days of the invention, companies placed telegraph lines in the most profitable areas. And as a result, certain cities became centers of communication, notably New York. Subsequently, when prices of bonds or stocks dropped in New York, they would drop in other states as well. And this happened because of the level of connectivity New York had with the rest of the states. The result? New York became the financial capital of the United States. By 1910, 90% of all bond and 2/3 of all stock trades occurred on the New York Stock Exchange. The steam engine triggered the first industrial revolution, and the internal combustion engine triggered the second industrial revolution, which occurred between 1870 and 1914. In 1876, Nicholas Otto, a German engineer, developed the first practical four-stroke internal combustion engine, known as the Otto engine. The engine used a mixture of fuel and air ignited by a spark plug and remains the foundation for modern gasoline engines. The IC engine was a lot smaller and a lot more efficient than the steam engine, and its ability to be easily stopped and started and run at different speeds made it ideal for factory machines. Subsequently, in 1886, German pioneers Carl Benz and Gottlieb Daimler patented the first IC engine-powered car. Their companies eventually merged in 1926 to form Daimler-Benz, which is today known as the Mercedes-Benz Group. The technology was subsequently adapted into the diesel engine in the 1890s, and that powered trains, ships, and heavy machinery. But the credit for popularizing cars as a mode of transportation goes to Henry Ford, who in 1908 introduced the assembly line-based manufacturing model, making automobiles affordable to the average citizen. The assembly line model entailed the breaking down of the manufacturing process into specialized tasks, which led to increased efficiency and a big reduction in costs. And as a result, mobility was democratized, allowing people to travel longer distances and live more independently. The IC engine gave a massive boost to the petroleum industry and several other ancillary industries. The IC engine was also quickly adopted by the military in vehicles like tanks and airplanes, changing the very nature of warfare in the 20th century. Space exploration, which was considered the final frontier, began in Germany during World War II with the creation of the V2, the first operational long-range rocket. Aware of the importance of rocket technology in future military campaigns, both the United States and the Soviet Union acquired the German rocket scientists post-World War II. The Americans acquired these scientists under Operation Paperclip, whereas the Soviets acquired them under Operation Oso Aviakim. The acquisition was controversial because most of these scientists had ties with the Nazi regime, but it was viewed as a strategic necessity for national security in the emerging Cold War. Initially focused on rocket technology to gain a military advantage, the technology slowly began to be used for launching satellites in space. On October 4, 1957, the Soviets launched Sputnik, the first artificial satellite to orbit Earth. And this was followed by the first human in space, Soviet cosmonaut Yuri Gagarin, who made one orbit around the Earth on April 12, 1961. The Americans, though, beat the Soviets in the space race when in July 1969, NASA, America's space agency, landed the first humans, Neil Armstrong and Aldrin Edwin, on the moon. The benefits from space exploration, though, were enormous. Space exploration revolutionized telecommunications, weather forecasting, and navigation, leading to everyday tools like the Global Positioning System, or GPS. Digital imaging technologies developed by NASA's JPL were used to create modern CAT scanners. But one of the most amazing outcomes of the space race between the Soviets and the Americans was that ultimately both sides began to work with each other and set up a permanent presence in space via a scientific research laboratory, the International Space Station. But space exploration itself would have run into a lot of obstacles had it not been for that one single path-breaking invention in 1947 at the Bell Labs, the transistor, which triggered the electronics revolution. Before the transistor, the electronics world was dominated by vacuum tubes, which were bulky, consumed a lot of power, and were prone to frequent failures due to overheating. A transistor is a semiconductor device that can amplify or switch electronic signals and electric power, and it is the fundamental building block of modern electronic devices. As the transistors made electronic devices smaller, engineers realized that shrinking the transistor further would revolutionize technology. And this led to the development of the integrated circuit, or the IC, in the late 1950s. The ICs allowed multiple transistors to be packed into a single semiconductor chip. And this miniaturization made modern tech, like the personal computer and smartphones, possible. In the early days, transistors were a few centimeters in size. But as the tech advanced, they became smaller and smaller, and today they are measured in nanometers, which is the billionth of a meter. And just for perspective, modern processors like Intel's Core i9 houses billions of transistors in a single chip. The electronics revolution took technological innovation to a whole new level, and Silicon Valley in California emerged as a primary hub of innovation. With the transistors and the ICs miniaturizing electronic devices, it was only a matter of time before the massive computers would get miniaturized and show up in everyone's homes. In 1975, the personal computer revolution took off as MITS released the Altair 8800, the first personal computer to hit the market. This was followed by Apple I in 1976, and the idea of a computer that could sit on a desk and actually be bought by a regular person became finally possible. The early PCs were very basic by today's standards, but they offered a surprising amount of utility for hobbyists, students, and families. By the late 1970s, PCs began to be marketed as household appliances. They claimed that they could manage finances, store recipes, teach kids math, and even water the lawn if hooked to the right accessories. The basic programming language made it easier for newcomers to get started, and it helped create a community of home hackers who were eager to figure out what these machines could do. The PC revolution gave rise to what is today a multi-billion-dollar software industry, which came about to create programs that would run on these personal computers. With the computer making it into the homes, it was just a matter of time before all these computers would start talking to each other over a network. So on January 1, 1983, the Internet was born. Prior to this, various computer networks which were very restricted to a certain group, like the ARPANET, did talk to each other. But there wasn't a standard way to communicate with each other. So a new communications protocol was established called the Transfer Control Protocol / Internet Work Protocol. That is TCP/IP. And this allowed different kinds of computers on different networks to talk to each other via a standard language. ARPANET and the Defense Data Network officially changed to the TCP/IP standard on January 1, 1983, hence the birth of the Internet. Initially, the Internet was used by researchers and scientists to send files and data from one computer to another. But in 1991, Tim Berners-Lee, a computer scientist at CERN, introduced the World Wide Web, an Internet that was not simply a way to send files from one computer to another, but itself a web of linked information that anyone on the Internet could retrieve. So the Internet as we know today was created by Tim Berners-Lee. In 1992, a group of students and researchers at the University of Illinois developed a sophisticated browser called Mosaic, and it later became Netscape. Mosaic offered a user-friendly way to search the web, allowing users to see words and pictures on the same page for the first time, along with the ability to navigate using scroll bars and clickable links. And around the same time, commercial companies began to set up websites of their own and started to use the Internet to sell goods directly to the customers. The impact was massive. An alternate mode of commerce came about, and companies like Amazon and eBay emerged as the dominant players in the online retail space. The Internet went a step further in the 2000s when social media platforms which connected people to each other emerged. Facebook, Twitter, now X, and Instagram emerged as dominant players in the space, and with the emergence of smartphones, access to the Internet multiplied several-fold, with more people accessing the Internet via smartphones than from other kinds of computers. As recent as 2022, OpenAI released ChatGPT, heralding the era of artificial intelligence and waking up a lot of the tech giants like Google, Amazon, Microsoft from their slumber. ChatGPT actually democratized AI. It brought advanced AI to anyone with an internet connection, moving it from a tool for specialists to something that millions could use daily. And in the process, it has triggered an AI race with all the tech giants who were fast asleep accelerating their own AI projects, leading to a surge in development and several new areas within AI. And as in the past, during such path-breaking innovations in technology, the question is being asked, will AI take away all jobs? And will machines get the upper hand in the human-machine interaction ecosystem? On that note, we end this section of the program. On to the quiz section. Question from the previous episode. Which was the most sought-after brand of steel in ancient times? An exceptional metallurgical achievement during ancient times was the production of Boots steel in South Asia, particularly India and Sri Lanka. It was highly sought after for its sharpness and durability and became the precursor to the modern crucible steel. So the answer is A, Boots steel from India and Sri Lanka. Question for the current episode. What was the first commercial domain to be registered on the internet? Was it A, Xerox.com in 1986, B, Symbolics.com in 1985, C, HP.com in 1986, or D, Think.com in 1985? Once again, what was the first commercial domain to be registered on the internet? Was it A, Xerox.com in 1986, B, Symbolics.com in 1985, C, HP.com in 1986, or D, Think.com in 1985? The answer will be provided in the next episode. That's all we have in the current episode. We meet again in 2 weeks with another interesting and exciting episode on world history. Till then, stay safe and keep exploring the why in history.